This video will describe all the steps to complete this custom guitar rosette. We begin with the slicing of thin strips of wood on the bandsaw, which we then use to produce multi-layer laminate boards. From these laminated boards, 48-piece segmented discs were constructed, which were then sliced to produce this custom guitar rosette. Additional rosettes of similar patterns are described in parts 2 and 3 of this video series. We begin by slicing the thin strips of wood needed for this project on the bandsaw using the Accu-Slice system. The Accu-Slice system is a system for the cutting of thin boards accurately on the bandsaw with no blade drift and getting perfectly straight and parallel pieces of wood off the bandsaw. Unlike a conventional system, which you would normally pass the board, like push it against the fence and pass it through the blade, the fence is actually removed from the bandsaw. And this Accu-Slice table is mounted onto the bandsaw table and has a long rail. And the board to be cut is mounted on a piece of MDF in this case, which rides on this carriage. And this carriage has roller bearings that ride on the rail. So as a result, you'll get nice clean movement of the board along the rail and through the bandsaw blade. In this particular case, I actually glued this board to this piece of MDF and mounted it to my sacrificial fence to this carriage. And these roller bearings will ride on the channel on the rail. So you have nice clean movement of the board through the bandsaw blade. My initial cut, I'm going to just square off the board so I have a nice straight parallel surface. All subsequent boards will be perfectly straight and parallel to that surface. There's an indexing wheel in which I dial in the exact thickness of the board I want to cut. So I dial in my thickness, lock my carriage in place, and then proceed to cut my board. When slicing boards with the Accu-Slice system, I cut as slowly as possible, because the slower you cut, the smoother the cuts. This first piece of wood just gave me a flat surface, and from now on I can dial in the exact thickness of the board I want. I know my blade kerf is around 45 to 50 thousandths of an inch. That is one full revolution of my index wheel on the Accu-Slice system. This index wheel is graduated in thousandths of an inch. One full revolution would be 50 thousandths of an inch, or my blade kerf. Then I just dial in the thickness of the board I want. So if I want a board 25 thousandths inch thick, 5, 10, 15, 20, 25, just dial it in, lock my table in place, and I'm ready to start cutting. Throughout this video, I speed up the video 10 times the actual cutting speed just to reduce viewing time. Okay, and there's my board off the bandsaw, and this board is perfectly flat and straight. If I measure with my vernier, I got 27 thousandths, 26 thousandths, 27 thousandths, flip the other side, 27 thousandths, 27 thousandths, 26 thousandths, and 27 thousandths. So you get a board, doesn't need to be run through the planer or a sander to get it flat. This is good enough to glue up for my laminated boards that I'll be making. In the same manner, I cut the remaining boards needed for this project using different woods and different thicknesses of boards. After cutting a number of different strips on the bandsaw using the Accu-Slice system, I took all these different pieces of wood I cut, and they varied in thickness from some as thin as 10 thousandths of an inch, others going up to maybe 100 thousandths of an inch thick. And then I assembled these into a pattern of these different woods, symmetric, with a center piece, and then going out from the center is symmetric. And I need to do that because I'll be inverting these pieces as I glue them up, so they need to be symmetric. And I assembled these into a pattern, a symmetric pattern, where you have a center board. In this case, I have a piece of purple heart, and going after the center piece, I have, of course, purple heart for the center, then yellow heart, some pudok, another piece of yellow heart, walnut, maple, pudok, and ending with maple again. So it's a total of 15 layers in this board, again, symmetric from the inside. And the idea is to get a pattern where you can see the distinguishing layers because of the contrast between the different woods. To glue up these boards, I'll be using my glue jig system, which I've showed in many other videos. on segment wood turning. It consists of 2 angle irons on a sliding rails, and I'll be putting my piece after they have glue. I'll be putting them in here inside this cradle of wax paper, and then clamping it with some spring clamps. And just the purpose of wax paper, just keep the glue off all my jigs so it keeps it nice and clean. So the first thing is to put glue on both sides of these pieces. And I'm using the West epoxy system. I'm using a cheap paintbrush to apply the epoxy. The paintbrush enables you to apply a lot of glue very quickly. And I am putting glue on both sides of the pieces to make sure I have good contact. When I clamp it in a glue jig, the clamps will squeeze out the excess glue. After epoxy has been applied to the last board, the assembly is then placed inside the cradle wax paper in the glue jig system. Spring clamps will be used to clamp them and squeeze out the excess glue. I'm ready to start clamping these. And these spring clamps work pretty good for doing these smaller boards. I usually clamp one low, one high, and just keep alternating them the whole way down. And once again, let that dry for at least 4 to 5 hours. A lot of excess epoxy squeezed out on both sides, so I need to clean that up. And the easiest way is just to run it through my joiner planer. So that's what I'll be doing. I'll run this through the joiner planer and get rid of that. And then I'll put it on my edge sander and get the excess glue off the outer surfaces. After cleaning up the edges on my joiner planer, I'll next take this to my edge sander to clean up the excess glue stains on the outer surfaces, and then it's ready for segmenting using the Accu-Wedge system. For my laminated board here, I'm ready to make segments. And what I'm going to be doing is I'm going to be cutting 48 segments and make a ring from those 48 segments. So I'm using my Accu-Wedge to do that, and I've set my table to 48 segments, per ring. Now I want my ring to be 5 inches in diameter. So there's 2 ways I can calculate how wide these pieces will be. First of all, I can use the Woodturner Pro software, and this software says to get a disc with an OD of 5 inches with 48 segments, my wedge needs to be 0.33 inches. So you can do it by using the Woodturner Pro software. The other way to do it is just by doing a simple calculation. I want a 5-inch wide disc. The circumference of the disc is pi times the diameter, which is 3.14 times 5, which is 15.7 inches. Then I divide that by 48, and I get 0.327 inches. And this program says 0.33. So basically 0.33, 0.327, one and the same. But between each of the wedges, I'm going to put a thin strip. And this strip measures 35 thousandths of an inch. So instead of using 0.327 for my wedge width, I want a wedge width of 3.27 minus 0.035, which is 0.292. So that's the dimension of the wedge I want to get off my system. So I have my Accu-Wedge system all set up, 48 segments per wedge. I got my stop set here. And I already cut a piece off here to give me a starting edge. So I push it against the stop, and I always try and push it in the center of the stop. And I can put my laser on to see where I'm cutting. And I said I wanted a size of 0.292. And that's just where I have it set on my system. Now I can adjust this by changing the stop here, in or out, to give me a shorter or longer distance. But right now it looks like it's right on. So I push the board against the stop, tight against the fence, and lock it down tight. And then I'm ready to make my first cut. Okay, this is my resulting wedge. And when I measure it, it measures 0.297. So it's about 5 thousandths too large. So I can make it a little bit smaller just by loosening my stop here, rotating it in a small amount, tightening it again, and then we'll run a second piece and take a measurement on that. Now I'm usually going from this fence to this fence. I usually take some 220 grit sandpaper and just sand that fuzzy off the edge. So again, against my stop, tight against the fence, tight down against my stop, lock it in place. And now my wedge measures 0.290. That's a hair too small, but I think it's close enough. I'll leave it at that, 290. It's only off by 0.02 of an inch. I have my laminated board with all these different pieces of wood in the middle. On the top side, you see I put a silver line off center. And that's important for re-gluing up in the future. Because what I'm going to be doing is, when I go to glue up, here's my two segments, and you see those silver marks. They have to go this way. You don't want to go this way, otherwise you're going to get an error. So the lines should be on the top side and alternate from top to bottom. That's why I made the line off center on the board before I started. So you keep alternating left and up, down as you go around your disc. And I'll be putting 48 of these together. And what I'll be doing is putting the spacer in between them. So it'll look like this. So without the gray mark, that's what it's going to look like. So now I need to make 48 of these segments. And I do that by going back and forth between the two fences. And I just repeat this 48 times. It's very important that you clamp your board. You cannot hold these finger tight. If you try holding with your fingers, the board's going to move. So I put it tight against that stop, tight against the fence, tight against the table, and then clamp it in place so it doesn't move as I'm cutting it. In order to reduce viewing time, I did speed up this video 10 times the actual cutting speed. So actually I'm cutting quite slowly. Well, I've cut 48 of these wedges, and now I need to sand them and also make the spacers. Okay, to cut my spacers, I'm using my little molding table saw, and I have my wedge here, and the grains in these wedges run this way. So I need to make spacers to go here, but I don't want to run it this way because I'd have end grain. I did that. So I want my spacers to run this way, so I have grain going in the same direction. That's going to be the top of my wedge for this segment of rosette I'm making. So I cut some thin boards. These boards were cut to 35,000 of an inch thick on the Accu-Slice system, and the height is the height of my wedge. In this case, it's about 1.5 inches tall. And so now I'll be cutting off thin strips, the exact width of my segment, which is 1/2 inch. These are 1/2 inch wide. So I go ahead and set that up. I have my system set up with a stop here. It's already been calibrated. So I just push it against the stop and then push it through the blade on the table saw. And I like this miniature table saw. It's a very small, fine blade, and it has a very small kerf, so I don't waste a lot of wood. So I push it against the stop, hold it there against my slide. And that's my first piece. So it'll go like that. It's a hair taller than my wedge because I'll be sanding it flush. What I'll be doing is I'll be gluing these on here and then sanding them flush in the next step. I cut a total of 48 spacers on this modeling table saw that I'll be needing for this project. Now my next step is to take each of my wedges and attach one of my spacers to it. I've already done it on a couple of these, so you can see how they're going to look at. This is 4 wedges which are put together. And you can see the gray alternating line on the top of them. And if you look at it on the other side, which doesn't have a gray line, that's what it's going to look like when it's finished. Now I know my disc is going to have an OD of 5 inches, and these laminated boards are each half an inch wide, so my ID is 4 inches. So I made, this is a high density polyethylene, high density polypropylene disc. It's the height of my wedges, an OD of 4 inches. And I'll be using this as a guide for my glue up. And I'll be gluing these up like this as I go around. And then I can put a rubber band on this to hold them in place and clamp them in place once I get to that step. So this next step is to actually start gluing these pieces on. But before I do that, I need to sand to get all the fuzzies off the edges. So what I'm doing is I'm taking each of my wedges, and where it comes off the bandsaw, there's usually a little bit of a fuzzy. You can probably see it here on that one edge. Actually, you probably see a little bit better from that angle. A little bit of a burr and a fuzzy. So that needs to be sanded smooth. So I just use some 220 grit sandpaper and just lightly sand the surfaces and the corners to get rid of all of those fuzzies. I need to do the same thing on my spacers, because again they have some fuzzies on the edges too, and the corners. So I get rid of the fuzzies, and the next step is to glue on these spacers. And I have my mark on these. I'll be gluing the spacers on the right side of my wedges. So this one will go this way, and this is the lower wedge. This wedge will go on this side. So that's the plan going forward. So I don't need this setup disc yet, but what I need to do is I'll be gluing each of these on there, and they're a little bit big. They're a little bit high on both sides. So I'll be gluing them on and then sanding them flush, because these spacers need to be perfect thickness of my segments. So I'm using Type-On 3 glue. I'll put a little bit of glue on my board here, put it on here. I have a piece of plastic which I can use as the piece on there, and then put some clamps on here to hold it in place. Put it on the right side, and then I have some small spring clamps to hold it in place. And as I'm clamping it, I'm adjusting it to make sure that that my spacers are a little bit bigger on both the top and bottom. I'm going to let that dry. Just keep repeating the process. Notice the maple spacer extends beyond the edges of the wedge. These will be sanded flush later. Well, that's 12 done. That's a quarter of them done. So these first ones I did now should be pretty much, glue should be set. So that's why I use these plastic pieces so they don't stick. Now I need to sand them flush, top and bottom. You can see they stick up a hair. So I need to sand everything flush now. Again, using the 220 grit sandpaper. Now, especially the bottom edge needs to be pretty much flush, because I'm going to be pushing against this disc, and for the disc to line up properly, it has to sit flat against this disc. And I can sand the top and bottom. Now the top where the mark is, if I sand that mark off, I had to put it back on so I remember where it was. So this is on the high side. And there's my first piece, all sanded flush. I said that'll go against this disc like that. And the next pieces will be adjacent to it. And I repeat the process on the remaining glued up assembly. I think now you can see why they need to be sanded flush. So when they're glued back together, the lines line up perfectly. After all the pieces were glued and then sanded, I then assembled them together on the form, put a rubber band around them, and this is the resulting rosette, ready to be glued up. Well, my 4-inch diameter disc was a little too small, maybe less than 1/16 of an inch. So I made it larger just by putting some rubber bands on it. So that brought it out probably about a 32nd of an inch, which is just enough to give me the right size ID. So I get a nice tight fit of all my pieces. So I'm going to be gluing this up in sets of 12. Now, none of these are glued up yet. I have 12 here ready to glue up, and I'll put those in here, add glue just to glue those 12, and then I'll rubber band them together and let them dry, and then I'll do the next set of 12. And I'm doing that because I think these, when I get glue in, it's going to stick to the rubber band. And if I didn't glue it in sections, it'd be hard to get off. So let me try it and see how it works. So I'm using, again, Type Bond 3 glue. Let's put this little rubber band on first so nothing moves. Then I get some thicker and heavier rubber bands to put on next, which add more clamping pressure. Now the ones I glued, I want to make sure that they're firmly sitting against this plastic, both top and bottom. I add multiple rubber bands just to increase the clamping pressure. And now you can see what it's going to look like. Just making sure all the lines are lined up, nothing sticking up too high. Because it's off by 1 or 2 thousandths, you'll see it, so I'm trying to eliminate that possibility. So let that dry for like half an hour, and then I'll do another set of 12. Okay, I'm ready to glue in the next set of 12. And I repeat the process for the remaining 3 sets of wedges. Okay, all my sections are done. So now I'm ready for the final glue up. Okay, this should be done. Here. After cleaning up the excess glue, this is what I ended up with. That's the one side. You see it's about 1.5 inches thick. Here's the other side. So going with the thickness here of 1 5/8. If I was to slice this off in segments 75 thousandths inch thick, so I get 75 thousandths plus another 50 thousandths for the kerf, I can get 12 rings from this glued up piece of segment at work. And this is the finished rosette assembly. Now I'll take this back to the bandsaw, and with the Accu-Slice system, I'll slice off some thin 75 thousandths inch thick rosette slices. Okay, next I'm going to glue my assembled ring to a piece of MDF. This is a piece of MDF about 6 inches tall, about 7 or 8 inches long. And I want to attach it to this because I want to put it on my Accu-Slice to slice off my thin layers. So I find the best way to do this is actually to glue it. I could use double-sided tape, but glue will make sure it holds the best. And I'll be cutting it all the way down to the glue line. And just a couple weights to hold it in place. Let that dry for half an hour, then I can put it on the Accu-Slice and start slicing them. Okay, I attached my MDF board with my segmented ring glued onto it, and I'm using my Accu-Sled 2 18-inch carriage. I could have used my 12-inch L bracket carriage, that would work fine, but I've been using these carriages more and more recently because they're just more versatile. So I put my 4x4 brackets on here, and I'll be cutting this ring. Now I just adjusted it to it's right against the edge of my ring. I don't want to waste any wood. And I zeroed my gauge. So, and I'm using a 3/4 inch wide blade. I normally use a 1/2 inch wide blade, but I'm doing some segmented. I don't want to change the blade. So this is a 14 teeth per inch, 3/4 inch wide blade. I said I normally use a 1/2 inch wide blade because the 1/2 inch wide blade has a smaller kerf. The kerf in this blade is around 55 thousandths, where the kerf on a 1/2 inch blade is 45 thousandths. So I'm losing 10 thousandths wood using this blade, but I'm just going to cut off maybe 2 or 3 discs from this, and I'll leave the rest on here that I can cut in the future when I need them. So I just zeroed it against the edge of my board. So 1 full revolution, which is 50 thousandths, which is about the kerf of the blade. And then I want to cut a board 75 thousandths of an inch thick. So 1 full revolution would be 50 thousandths. And then another 25. That should give me a board 75 thousandths of an inch thick. So let me go ahead and cut this and we'll see how we do. And there's my Rosette ring, 75 thousandths of an inch thick. And it at 14 tooth per inch blade gave a real nice cut. So let me cut a couple more on these. So again, release my mag J clamps. 1 full revolution for the kerf of the blade. And then back to 0 is 25 thousandths. And then 1 full revolution with another 50 thousandths. And then ready to cut another ring. And you notice I'm cutting slowly because again, the slower you cut, the smoother the cut. But this 14 teeth per inch blade does give a very nice cut. Now the kerf in this blade is a little more than 50 thousandths of an inch, so this is probably less than 75. And it's actually 66, 67 thousandths. Usually between 50 and 75 thousandths is a good thickness for these rings. And there's our 3 rings. In this video I created this segmented disc, which is 5 inches in diameter by 1.5 inches thick. The segmented disc is comprised of 48 multi-layer segment wedges with a thin maple spacer between each wedge. From the segmented disc I sliced off 3 guitar rosette discs. Each rosette was sliced to 70 thousandths inch thick. The remainder of the segmented disc is being saved for future needs by customers or demos at trade shows. The outer layer and spacer between the wedges of this rosette is maple. The inner multi-layer laminates include thin strips of padauk, walnut, yellow heart, and maple woods. 2 additional rosettes of a similar design will be described in the next video in this series. Additional rosette patterns are also planned. Once again, thank you for watching this video. If you have any questions or comments, please give us a call or drop us an email.